Well, thanks for inviting me to speak. I'm Joachim Ganseman. I work for Smals. Some of you may know Smals. We are an IT provider for the government. We work exclusively for the government, and we have a little research division of which I am part. So in this research division, we investigate all sorts of new technologies, upcoming technologies, and we try to see can they be of use in government processes, in government software, and so forth. So aside from artificial intelligence, which is like an obvious hype to study right now, that includes like new kinds of databases, augmented reality, knowledge graphs, everything that has to do with security and cryptography and so on. So the topic today is artificial intelligence, and I do want to talk mostly about the failures of artificial intelligence, where it can go wrong. But this is not supposed to be like a non-encouraging talk or a discouraging talk. AI is already there and we use it. There are lots of useful applications already in our daily lives. So there are spam filters, machine translation, autocomplete, and anything that has to do with recommendation, anything that has to do with smart home. It makes life easier. So it's not. There are really lots of good applications of artificial intelligence. But people are very enthusiastic, and in their enthusiasm, yeah, they try and overdo things. Sometimes they don't really take all the factors into account, and that's what this presentation is about. And I'm going to subdivide that in four like general categories. The first one is more targeted towards developers. If you are a developer and you're building an AI, what can go wrong? Then I'll go towards deployers. Once an AI is deployed, what can go wrong? You as a citizen, you're subject to AI as well, to AI solutions. What are the dangers there? And is there anything that we can do against all the negative effects? So to sum this up, what can go wrong screwing it up yourself, or can someone else screw with you? So let's start from the developer perspective. So if you build an AI system, a machine learning system, it's built on data. And with all things regarding data, there's an old truth that is still true today. Garbage in is garbage out. Your data needs to be as good as possible. And in machine learning systems, that usually translates to, well, you want your data set to be more or less independent, identically distributed if you want to express it in a statistical way. But in normal speak, that means like you want your data set to be well balanced and free from any hidden correlations. That's the theory, but in reality, that's rarely the case. There are correlations. An obvious one is the correlation between your first name and a gender. If you hear a first name, you can very often derive what gender a person is. Datasets are limited, and it also means that the result that you get out of any AI that's trained on a dataset will also be limited. And to just give an example, like in June this year, there was a little bit of a controversy around the new system that was built, the face depixelizer. Give it a pixelized image, and it will try and build a face around it. And that works pretty well if you use it the way it's intended to be used with faces. So not long after, people also tried it with faces from video games, and with completely nonsensical images as well, and it still tries to produce a face. But the big controversy was when someone tried it on an image of Obama, and a totally white person came out in the end. And you can see that this was not really met with applause in many circles. So what went wrong here? Well, two things actually. First of all, there's the dataset itself. So this training dataset that they used for this system, it's built on Flickr. It's an excerpt from Flickr, and that dataset just is mainly composed of white male people. Not only that is a problem, there's also a bit of a problem with the methodology that was used, like the actual algorithm that was being trained. This method, the generative adversarial network, is a bit sensitive in that it overvalues the average. If your average in an unbalanced data set is still a very white, very male person, then it's gonna output even more white people as a result. So the choice of algorithm here was also maybe not the best. It was really not good to get a diverse result. So this is a very easy problem to detect. So the question now is, well, like, if you have a non-visual artificial intelligence system, say an artificial intelligence system that has to decide on whether you will receive a mortgage or not, are there any of those kinds of biases built in as well? So in short, AI systems, they inherit the biases from their creators. So we as humans, we are biased. If you've no idea how, well, I do invite you to check out this Wikipedia list, an article, the list of cognitive biases. It really lists 200 kinds of biases that we are all subject to and that are all that we all unconsciously live by. These are all common things, like we all like to hear what we believe ourselves, stuff like that. So if you're human and you're biased, or you live in your own bubble, you're limited in your own particular ways, then any data that you'll collect will likely also have a bit of bias in it. And then you have a biased data set, and that biased data set leads to a biased AI system. So especially in the case of face recognition, the case of not detecting non-white faces, it's been existing for years already. So this is here an article from 2009. There are similar articles. Wait, why is nothing happening? Come on. Yeah, there are similar problems in several years later. This is from 2017. Even like 1 month ago, like 19 September this year, Zoom had some problem because they also use background subtraction, and they tried to detect the background, and their algorithm actually thought that black people were part of the background. This is a huge case of bad publicity. You don't want this happening to your company. So yeah, still today, these kind of things happen often. I'm going to go a little bit deeper on this case. It's a case from 2 years ago now, October, actually exactly 2 years ago now, where Amazon tried to build a system to screen CVs and see can we automatically decide whether they're good fits with the company. So it turned out that their system that they built actually had a bias against women. So what was behind that? Well, they're not stupid at Amazon. They thought like, okay, we're gonna fix this by not taking protected characteristics into account. So we won't even take into account the variable gender as a variable in our machine learning system. And that way, the entire process is blind to gender, and the system will be unbiased towards gender. But this is not exactly correct, because there are other variables that are correlated with gender, and language use is one of them. So men and women have different ways of speaking, and I've posted here 2 word clouds of teenagers on social media. I'll let you guess which word cloud is of the male teenagers and which one is of the female teenagers, but it's very, very clear that they use a very different vocabulary. And this kind of difference in vocabulary, it's pervasive into adulthood as well. It also happens in CVs. And this way, just by the way that words were used and the kind of vocabulary was used, the analysis system of Amazon still had a bias against women, even if they didn't explicitly take gender into account. So gender, as it turned out, was what we call a prominent confounding factor. So confounding factors, they're important in machine learning. They're actually hidden properties, so properties that you wouldn't pay attention to, but they're there, and they do influence the properties that you actually know and that you actually listed up. Sometimes these things, they lead to surprising new insight, and this is, for example, an example of authorship detection, where it turns out, yeah, what do you want to, how do you want to decide who is the author of a particular book? Well, you'll look at the kind of words, the kind of vocabulary they use, you'd say at first. It turns out that sometimes it's even enough just to look at the punctuation. It doesn't even matter what kind of words they use, what kind of language they use. Punctuation already can tell you a big deal. So these kinds of new discoveries, they do get made because of this. What I want you to take away from this is that AI systems don't necessarily learn what you want them to learn. So yeah, what can you do against this? Well, do better investigations into the data, better sampling of the training data, do thorough analysis. Yeah, you can't do that infinitely for sure, but try to do them as good as possible. I must say that not all bias is unfair. Sometimes biases are natural or they're inherent to the kind of data set. This is particularly the case with diseases. Some diseases you can only get as a man, and some diseases you can only get as a woman. And no one's going to say that if that results in a certain gender bias, that kind of bias is unfair. This is a natural bias, a naturally occurring bias. It's a bias, but it's fair. The biases that we want to prevent are biases that are unfair, that are based on things that should be equal across the board and that may have serious consequences. For example, in security decisions, who gets picked out to be checked at an airport control, who gets inspected. They could be legal decisions or economic decisions, for example, who gets a mortgage and who doesn't. There are tools that that can help to spot unfair biases, and I would especially point out a tool set from the Media Lab of MIT, the AI blind spot tool set, and the list of tools that is collected by the Knowledge Center for Data and Society at Kenniscentrum Data en Maatschappij in Flanders here. They really do a great job in keeping an eye on all the stuff that exists that can help you build fair AI systems. Also, if you're still looking for a good present underneath the Christmas tree, great book to read about the societal impact of some of those problems. So know your data, know your algorithms, and know their limitations. That's the point. Last thing, if you're building an AI system, well, you're actually building some sort of optimization system, an optimizer. What do optimizers do? Well, they minimize a loss or they maximize a reward. And that's sometimes really hard to define. Also, sometimes because it's just computationally very complex to compute, and you really want to have a simple objective that's easy to optimize against. So you're going to try and simplify the problem in such a way that you have a nice function that is easy to optimize. And sometimes that leads to some oversimplifications. Now, AI systems, they will follow the specs, they will follow those specifications, but if you're not complete, they might exploit bugs or unexpected data properties or get stuck in loops. And here on the right is, for example, a guy who tried to program his Roomba not to bump into walls, and the Roomba just started continuously driving backwards because it didn't have sensors on the back. So there's an entire data set of stories like that, dozens and dozens of similar stories. That's the specification gaming spreadsheet. It's available through the link here below. It's a lovely read. If you want to have a good laugh, I encourage you to go check it out. So good, you've built an AI system, it's fair, the data has been well checked and validated, all good, all is well, you're gonna deploy it and you're gonna put it in the wild. And then you get confronted with users. Now, users can also do their fair share of, cause their fair share of trouble if they have to use an AI system. First thing I want to highlight is the concept of data poisoning. Data poisoning happens when users or an external actor actually has access to your training dataset. And they inject false data to compromise the learning. They can do that by intentionally mislabeling stuff or by just injecting new data that doesn't make any sense. So for example, when everybody could still edit Google Maps or make suggestions of Google Maps, at some point the White House was named the nigger house when Obama got into office. Well, this is also not good publicity for Google. And also web scraping poses certain kind of risks because, well, you're going to rely that some data set that you're going to scrape off the web is actually reliable. And that's not always the case. Actually, 1st of September 2020, so that's just only 1 month ago, it was discovered that the Scottish Wikipedia was actually not written by anyone who knew the Scottish dialect. Yeah, if you're going to use that to train a language recognizer or a translating system, yeah, your translating system is going to suck. So it's a risk. You need to take this into account. You need to validate or verify your data. It's not a luxury. Second possible kind of attack is the famous adversarial example, and that's especially famous in the case of deep learning. So what happens here is if you learn across a very large area of possibilities, let's say all the possible pixels in a certain image, then you're gonna end up with a system that's overly sensitive to small changes, or that risks to be overly sensitive to small changes. Small changes into input image might actually make that the system recognizes something completely different. But I must say this is not only the case with images. You can have the same thing with sound. You can do slight perturbation in the sound, add a little bit of noise, and suddenly have automatic speech recognizer output something completely different. So adversarial examples are actually a problem in most AI methods, regardless of the formats, and they're often robust, which means that, yeah, you can change a few pixels, you can put a sticker on an object, you can even 2D or 3D print objects and show them in front of a camera, and in some way you'll find a way, you'll find there are always going to be ways in which to make the system think something that it shouldn't think. That's especially dangerous, of course, in the case of autonomous driving. If your car suddenly doesn't recognize traffic signs anymore, you can imagine this is a huge safety hazard. And the problem isn't really solved yet. So you can retrain and keep training, but there are limits to that. There's still a lot of research being done in how we can make all these kind of systems more reliable. So what's the problem here? Well, yeah, curse of dimensionality. There are so many possible combinations of pixels in an image that could represent so many things. This is impossible to build a training set that covers all the possibilities. And therefore, yeah, if you have a limited set of things to recognize, you might actually overfit the system, and then it cannot generalize anymore. So then you yourself as a citizen, even if you're totally blissfully unaware of artificial intelligence and what it does to you or what the applications are, you can still be disadvantaged by AI systems that exist or that are deployed by third parties. Maybe one of the better examples is phishing. You can imagine, well, everybody knows phishing. Everybody knows what phishing is. We have seen very directed phishing attempts, as even more credible attempts recently are starting to pop up. But if you combine that with artificial intelligence, well, what could a system like that do? Suppose you have an intelligence that goes scraping for social media profiles, and they build up a profile. They know where you go sports. They know which banks or which companies you're clients of. They could really screw you over and start contacting you with carefully constructed emails that seem to really come from businesses of which you are a client. It's an ever-increasing risk. Even so much that they're starting to launch a new term for it. After spear phishing, we've got laser phishing. So phishing that's so well pointed towards a target and so personalized that it becomes even hard for people like, for well-educated people that are familiar with phishing, that are experienced, to actually detect it. What else is there? Well, we all know about fake news, disinformation, fake news, which is also spreading and which can easily be generated and easily be amplified. So before I start going a bit deeper into that, I want to make sure that that we have a very good definition, because a lot of things get classified as fake news now, and it's not always really fake news. So I'm going to adopt a definition by the European Commission, and they say, well, to be fake news, something needs to be really verifiably false and be intentionally made or disseminated for economic gain or for deception in such a way that it really might cause public harm. So that means that, okay, extreme political opinions, they might be extreme, they might be not your political opinion, but it's not necessarily fake news, it's an opinion. Same with unions or lobbying or advocacy, being selective. With religion, things like those generally don't count as fake news, they count as opinion. Fake news, they can be generated. Actually, in the case of images, we're already there. If you look at the progress over the last few years, since let's say 2018, we can generate really believable images of people. There are websites about this now. thispersondoesnotexist.com. You can go there right now and generate yourself a profile picture for a fake profile that you want to make. It's going to be so sharp that nobody will know that it's actually a fake image. These kind of technologies are also used to like blend in with existing images, or like really create fake videos, fake sounds. Those are the deep fakes. We'll see them popping up more and more, and they risk to be used in campaigning, for political gains, for personal gains, and whatnot. It becomes harder and harder to detect those by themselves. And of course, the internet would not be the internet if it would only generate images of people. There are now also fake cat generators. There is a companion website to This Person Does Not Exist, which is This Cat Does Not Exist. You can generate an infinite amount of non-existing cat pictures. So there you go. If you don't know what to do with the Christmas holidays, endless source of fun. Not only images, also text can be generated, and the latest new model that's been going on in the news that people have been talking about is GPT-3. So GPT-3 is an enormous model. You can't really build that yourself. You need an insane amount of resources and money to do this. But at OpenAI they did it, and the system is so powerful. It doesn't only generate prose. It can be used to generate code, well, simple code, I must say, like small CSS scripts, small code snippets, but snippets that actually work and make sense. So you can describe a layout and have CSS generated for you. It might actually lead in the long term to some speed ups in coding. It can do really good translations. It can do some basic mathematical reasoning even. But it's not perfect and not intelligent. It's still a generator. Sometimes it generates nonsense. So it doesn't really know what it's talking about. It's still a system that works based on statistical correlation. So which word should I use now that will probably be okay? It's still a probabilistic system. So it still has its limitations. But for like small texts, let's say tweets or small paragraphs, it can generate really convincing outputs. So there we are. We have a technology actually now already to fill up Twitter, email, websites as much as you want with reasonable sounding text, with realistic images. And if you have access to a botnet and every bot makes one, then you have yourself a little bot army with a small social, with a a realistic social media profile behind it, you can actually create quite a lot of havoc. So yesterday, that's 24 hours ago, a news story broke loose. That's actually someone had actually built GPT-3 bots to post comments on Reddit, and nobody had noticed. So we'll see more and more experiments like this popping up, and it remains to be seen where this is headed. But this becomes possible. It's now just a case of gluing the necessary technologies together to potentially have quite a large impact. This impact that you might have is amplified by the use of recommendation systems. And especially YouTube has had some bad rep about this, in that if you look at the recommendation system, the recommendation algorithm behind YouTube, you'll see that if you start watching videos on vegetarianism, you'll soon end up at videos on veganism. And if you watch videos about jogging, you'll soon be watching videos about ultramarathons. So there's this push towards the extreme, and the extreme keeps us excited as humans. It keeps us watching, and if we watch more, YouTube likes that. So what's this kind of interesting content that might be promoted in order to keep us watching? Well, for example, flat Earth videos, or videos that spread conspiracy theories. Now, I'm singling out YouTube here, but this is not only the problem of YouTube. This is actually the problem of any recommendation system on any platform. Instagram is at least as bad. TikTok, the same thing. Whatever you read on tabloid websites is the same kind of dynamic behind it. So what is this dynamic? Well, basically, you as a consumer, if you go to YouTube, you want to find good information. But this is not the objective that YouTube has. YouTube wants you to watch as much advertisements as possible. These objectives clash. So what YouTube actually has implemented is not a feedback loop, not an AI system that optimizes your objective, but that optimizes their objective. And that objective is, to get more views. So instead of pushing the content that you would actually need to consume to attain your objective, like the good information, to push good information, they'll post inflammatory information, inflammatory content to make sure that you keep watching. Now, they're well aware of that. There has been some societal backlash. They've promised that they'll do something about this last year. They have implemented a few steps, like stuff like fake moon landing videos. They are not shown to children anymore, things like those. It remains to be seen whether this is enough, whether this may be too late. You also see Facebook, for example, having very recently decided to ban all QAnon groups. It's part of the same battle against the worst sides of this feedback loop problem. We'll see whether this actually leads to good enough results. So far, I'd say results are mixed. So what else do we have as by way of societal impact? Well, we as users, we don't have free choice anymore in what we watch. We don't get presented unbiased information anymore. So we risk ending up in echo chambers. We get to see stuff in which we are interested, and we no longer receive or easily have access to a wide variety of other information. Very much the same like if you go listen to 100 hours of pop songs on Spotify, the next 100 hours will also be all pop songs, and you won't be easily diverted into classical music anymore. So what do you get with that? Well, if the stuff that you get presented is more and more extreme, well, that extreme content gets mainstreamed. In the long run, it might lead to the proliferation of conspiracy theories, erosion of trust. People don't know anymore what they can believe and what not. But the entire system can also be used for particular gains. The best known example maybe is the US election of 2016, the election of Trump, where the conversation about Hillary Clinton was so much dominated by Republican-owned outlets and Republican-made videos that anybody who looked up information about Clinton on YouTube, on social media, would, with almost 80% certainty, be served a video will be served a video about Trump later. So this was really a question of who owns the conversation, who owns the narrative. This analysis is well known, and we'll see whether for the next election, the upcoming election, they will have done something about it. I'm not really sure if they're up to the game yet. We'll see. And then again, you end up in the area of information warfare. We also know this in Europe, by the way. This is not a problem that is unique to the United States. We see this, for example, in the stuff that Russia is trying to push around the Crimean War, the Ukraine crisis, the downing of the MH17 plane, and whatnot. So we in Europe, we're also subject to that kind of stuff. Good, then, yeah, how to defend against all this? Can we do something against this? Well, I'm not a social scientist, I'm a computer scientist, so I'm going to stay a little bit, I'm not going to go too deep into everything, but I do want to point out a few things that I find personally interesting. In any case, if you are interested in this kind of stuff, I would really say invite a social scientist maybe to come and talk about these things that are more specialized in this kind of dynamics. So as a technical person, well, you can defend to some extent against making AI systems that are biased. There are tools. There are more and more tools being made. They are also made available on GitHub. Even the large companies like IBM, Microsoft, Google, they all have their tools available. They're really actively researching this. There are entire academic conferences being organized around the concepts of fairness, accountability, transparency, ethics, traceability, and whatnot. Under the general term of explainable AI, we're also seeing some tools that make auditing of AI systems possible. And this is an important factor in accountability, especially if you make any decision that needs to have a certain legal value, you need to build in a certain amount of accountability. That's especially hard when you do deep learning, and that's still in its infancy, so we see more and more things popping up. It's going to be one of the major areas of research in the next 5 years for sure. As a citizen, you need to be aware that you're being profiled, especially on social media. Social media are profiling machines. Anything you write on there can be used against you, and the stuff you see on there has been redacted for you and is not what someone else sees. So social media companies are themselves also making some initiatives, and on the right here I've made an excerpt of Facebook having implemented an algorithm that goes analyze posts and see if there's a suicide threat going on. That in itself raises some questions. Is Facebook actually allowed to do that? Can Facebook share these results maybe with other people? Can they actually call law enforcement on that? It's an active debate, I would say. It's not solved yet, but it's an interesting debate, and we'll see it being debated in the upcoming years in more detail for sure. Also, what to do as a citizen? Well, rely on authoritative, transparent sources. These are more important than they ever were. They include peer-reviewed science, and they include quality journalism with all the defects that those systems have. It's still the best we have. They're certainly not perfect, but it's the best way we have if we ever want to get into objective view of the world. So we do need to encourage some amount of digital skepticism. Sorry. So don't believe everything you read on the web. Don't believe those flat Earth theories. Don't believe those QAnon theories at face value. It doesn't mean that you have to be paranoid about everything. You don't have to be believing in enormous government conspiracies, but you have to have a good skeptical attitude, questioning attitude, and for certain, keep on thinking yourself, like a reason for yourself. It also requires, of course, some competences and literacy if you want to do that. For that, we do rely on some government intervention, like provide good education, good training, good journalism, good news resources, make sure that those are widely available in public libraries. Yes, these things all cost money. It's useful in the long term to make sure that people can actually make sense of the stuff that they see and that they will see in the upcoming years. As a policymaker, you need to be aware of your own vulnerability to pre-selected information. If you're in a leadership position, you're not exempted from this. You actually might be a target to some laser phishing attempts or CEO personification attempts, for example. You need to be aware of those feedback loops that lead to overrepresentation of extremes, and you need to be aware of information warfare. It actually happens. So what to do as if you're in a position of power? Well, stimulate the media, stimulate innovation, stimulate research also on the impact of innovation and on the broader societal consequences, and establish a culture of permanent learning. Those are the best defenses probably from a societal point of view. I'm gonna quit with some links to initiatives that are being undertaken in those domains of fairness, ethics, and education of the general public. So the Knowledge Center for Data and Society at Kenniscentrum Data en Maatschappij is probably one of the most important ones in Flanders. They do an enormous amount of work. They have really good resources. And they really write excellent articles as well. Their newsletter is highly recommended. And they really do an enormous effort to educate people to go outside of the bubble of academia and go towards the public. It's a fantastic initiative. Fact-checking happens, among others, by journalists from CNAC, from VRT, and on the French-speaking side of the country, Fakey and Open Facto. In the Walloon area, there's also the Réseau d'Intelligence Artificielle, and on the Belgian level, AI for Belgium, that kind of tries to get all those actors communicate and connect with each other. So I wanted to say a bit on the legal implications as well. So the GDPR says something about being subject to an AI. Basically, it says that you cannot be subject to decisions solely on automated processing, except when you've given explicit consent. I'm not a lawyer, I'm going to leave it at that. The GDPR, though, does provide some amount of protection already against abuse and might be a good defense if you ever need legal defense, let's say. And also on the EU level, there are initiatives being undertaken, task force against disinformation, codes of practices for industry, and the guidelines for trustworthy AI. Good, there's some further reading there if you're really interested in this. There's a malicious AI report, which is really good from France, the Villani report as well. Some stuff that's been done by the OECD, that's USO, and organizations in academia that are also specialized in these kind of areas. Good, with this I'll close, I think, because I'm already speaking for 40 minutes and it's a high time that I finish talking. Yeah, long story short, try and discover all those things that can go wrong in all the stages of the AI building, deploying, and using process. Good, thanks. That was me. Do feel free to get in touch if you want to hear more about this. We at Smals Research, we regularly give presentations, mostly geared towards people that work on projects for the public sector and for governments. If you're working on these kinds of projects, do check us out, subscribe to our newsletter where we will announce upcoming seminars and presentations about other topics as well. There's one on cryptography planned somewhere in November, I think. So yeah, if you're interested, you're certainly welcome there. And then Kevin, the floor is yours. If there are any questions, I'll be happy to take them.
Okay, thank you, Joachim. It was a very interesting talk. If there are there any questions, then you can ask them now in the chat, or you can get them to me and I will forward them later. And if not, then thank you again, Joachim, for your interesting talk.